Okay, so today we're learning about integer exponents, which you already have some experience with. These two rules should already be in your notes. Zero exponent, any term raised to the power of 0 is 1. And the negative exponent, to make it positive, we put it in its opposite spot. So like this one's in the numerator and it went down to the denominator, same with this. But if your negative exponent was in the denominator, you would put it in the numerator to make it positive. So the first problem we're going to look at is a story problem. It says the diameter for the Model A Ford piston could vary by at most 10 to the negative third inch. Simplify this expression. So 10 to the negative third is written like that. In order to make this negative positive, we move it to its opposite spot, which would be the denominator. So now we have 1 over 10 to the third, which looks like this, because that third power tells us we multiply 10 by itself 3 times. 10 times 10 is 100, 100 times 10 is 1,000. So when they say simplify, and they want to see the answer without an exponent. Another one they have, these ones just give them to you 2 to the negative third. In order to make that exponent positive, we put it in its opposite spot. So we move it to the denominator and it becomes positive. And that tells us we're going to multiply the 2 by itself 3 times. So we get 1 over 2 times 2 is 4, which times 2 is 8. So this is our answer. The next problem is 5 to the power of 0, which just equals 1. You could have a big, huge, long term. You could have like x squared, y fifth, z squared, a to the first, and it could just keep going on forever. And if it's in parentheses with the 0 outside, that means the everything inside the parentheses is raised to 0, so it equals 1. Let's look at some negative bases. So we have negative 3 for our base in parentheses, raised to the negative 4. So we want to put that in its opposite spot. We do not remove the parentheses. That negative stays. The only negative that switches to a positive is on the exponent. Now when you have a base in parentheses, you keep that in parentheses, and it repeats exactly what's in parentheses. So it's negative 3 times negative 3 times negative 3 times negative 3. So we have 1 over 1, 2, 3, 4 negatives, which is an even amount of negatives, so our answer is going to be positive. And then we have 3 times 3, which is 9, times 3, which is 27, times 3, which is 81. So we have 1 over 81 for an answer, and it's positive because our number of negatives was even. Now sometimes your base will not be in parentheses, as in this case. So when that happens, still your negative 3 stays negative. When you move it to the denominator, your exponent goes to positive. However, when you rewrite this, the negative only stays with the first time you write the base. The second, third, fourth, and so on, if you had a higher exponent, are all positive. That means we only have 1 negative, so our answer is going to be negative, because it's an odd number of negatives. We have 1 and then 81, because we figured that out up here, that 3 to the 4th power was 81. So if your base is in parentheses, the negative sticks with it every single time you write it out. If your base is not in parentheses, the negative only stays with the first time you write the base out. Alright, the next set is evaluating expressions, which means they're going to give you something like x to the power of negative 1 for x equals 2, and wherever you see an x, you put a 2. So we have 2 to the negative first power. Since this base is positive, when we rewrite it, it doesn't matter if we leave it in parentheses or not, because it's positive. And it's to the first power, which means we're only going to see that number 1 time, so our answer is 1/2. Let's look at this next one. We have a a to the power of 0, b to the negative third 4, a equals 8, and b equals negative 2. So we can just eliminate that variable right there because it's something to the power of 0, which is just going to equal 1, so it doesn't change anything. So now we're just looking at b to the negative third. So we have negative 2 to the negative third. Our bases in parentheses are negative, so every single one of our denominator bases is going to be negative 2 in parentheses, but when we move that, so 2 to the third, which means we're going to have 3 negative 2's in parentheses. Since there's 3 negatives, that's an odd number. Our answer is going to be negative, and we're going to have negative 1/8. Okay, the next problem we're going to look at is 3y to the negative second. Now, that whole number here, we don't have to worry about. The only thing we have to worry about is making this exponent positive. And in order to make that positive, we need to put the term it's attached to in the denominator. The term it's attached to is y. So we move the y to the denominator, the negative switches to positive, and the whole number stays in the numerator. The next one we have is negative 4 over k to the negative fourth. So we see here that we have a negative exponent. We don't like negative exponents. We want to make it positive, so we want to move the exponent and the term it's attached to its opposite spot. So this 4 is already negative, and that's okay. The whole number can be negative, but we move the k to the numerator, and when we do that, the 4 switches to a positive exponent when it crosses the fraction bar. One more. We have x to the negative third over a to the power of 0, y to the fifth. Now, a to the 0 doesn't do anything, so really we have x to the negative third over y to the fifth. Now that y to the fifth is already positive, so we're going to leave that in the denominator, because if we were to move it to the numerator, it would become negative. Then this negative 3, we want that to be positive, so we need to move its base to the denominator and change the numerator to a positive. However, when everything is in the denominator, you cannot leave the numerator blank. So we always replace it with a 1. So if you move everything from the numerator to the denominator, the numerator has to have a 1 in it. So, that's what you're doing today. You're doing like 1 through 75, every other odd. But I think that's only like 20 problems. So, just remember, you want your exponents to be positive.